All right, we are on the last section for Module A, finally. And this is going to be an introduction to Algebra of Functions. This is not a high priority section. This is something that you will explore further in Math 121, but just to kind of help you out, we're going to go ahead and introduce it here. So in the past, we have seen that you can add numbers, you can add expressions, you can add equations, and since functions are essentially equations, you can add functions, as well as subtract, multiply, and divide. So one thing to note, there are two notations that we're going to see. We're going to see the operation inside parentheses, for instance, f plus g, f minus g, f times g, and f divided by g. Now what these are actually equal to is f plus g of x is actually equal to f of x plus g of x. Similarly, for subtraction, we get f of x minus g of x. For multiplication, we get f of x times g of x. And for division, we get f of x divided by g of x. Now we're going to do a couple different things with these. We're going to first come up with some actual functions, and we're also going to evaluate these functions. So let's go ahead and look at some examples. So for example, for our first set that we have, we're going to let f of x equal negative 2x plus 3, and we're going to let g of x equal x squared minus 1. So the first thing that I want to do is I want to find a new function, f plus g of x. So in order to do this, again, remember those definitions, they mean the same thing. So what we can do is remember that f plus g of x is also the same thing as f of x plus g of x. Now to find the new function, all we're going to do is replace the function name with its expression. So for instance, where we see f of x, I'm going to replace that with negative 2x plus 3. And where we see g of x, I'm going to replace that with x squared minus 1. Now that we have a new expression, we just want to go ahead and simplify by combining like terms. So if we go ahead and simplify this, it doesn't matter what order you write it in. I'm going to go ahead and kind of start you off by getting you in the right order for our next module. I'm going to put x squared first, minus 2x, and 3 minus 1 is plus 2. And so this is our new function for f plus g of x. All right, now that we have that definition, let's go ahead and try example B. Example B, it says we want to find f of 3 plus g of 3. And there's two ways that you can do this. What we can do is we can find f of 3. And remember that to evaluate the function at 3, we're just going to plug 3 in wherever we see an x. And simplify. So we get negative 6 plus 3, or negative 3. Now that's the first half. The second half is to find g of 3. same thing in my g of x function. I'm going to replace all my x's with 3's. So we get 3 squared minus 1. We get 9 minus 1, which is equal to 8. This is my g of 3. I can finish this off now. Now that I know what f of 3 is and g of 3 is, we want to go ahead and add these two numbers together. So we get f of 3 plus g of 3 is equal to negative 3 plus 8, or 5. So this is one way that you can do this. The other way you can do this is by using the function definition that we found for f of g plus 3, or f plus g of x, is we can plug it into this function right here. And let's see what happens when we do that. So if we go f plus g of 3, we get 3 squared minus 2 times 3 plus 2. And if we simplify this, we get 9 minus 6 plus 2. 9 minus 6 is 3, and 3 plus 2 is equal to 5. So notice that no matter how we do it, we get the same thing. So it's up to you as far as which method you want to use in order to simplify this, in order to evaluate this. So let's try a couple more examples. Let's look at g minus f of negative 2. So I'm going to go ahead and use the function definition. Let's go ahead and find g minus f of x first. So remember that this is going to be g of x minus f of x. And if we do that, we get g of x is equal to x squared minus 1 minus, make sure that you do put parentheses on this one, because we do want to subtract the whole function, so we need to distribute our negative. If we do that, we get x squared minus 1. Distribute our negative, we get plus 2x minus 3. And so this is equal to x squared plus 2x. I can combine my constants and I get minus 4. So this is our g minus f of x. So now to find g minus f of negative 2, let's go ahead and replace all of my x's with negative 2. If we square negative 2, we get 4. 2 times negative 2 is minus 4. Minus 4. We can cancel a positive 4 and a negative 4, and we are left with negative 4. Now for part D, as we have not talked about multiplying, these are considered binomials. I'm going to use my other method. I'm going to find f of 4 and g of 4 and then multiply the numbers. So if we find f of 4, we get negative 2 times 4 plus 3. This is negative 8 plus 3, or -5. G of 4, if we plug in 4 to our G equation, we get 4 squared minus 1. This is 16 minus 1, or 15. Now what did we want to do? We wanted to multiply. So we're going to take our f of 4 and our g of 4 and multiply them together. We get -5 times 15, or -75. All right, let's try a couple other examples just to make sure that we got it. We got some new function definitions. So for f plus g of x, same thing. The first thing I want to do is I want to start by adding my functions. So we want to do f of x plus g of x. And if we do that, we get x squared plus 3. We're going to replace f of x with x squared plus 3. We're going to replace g of x with 7 minus 2x. You do not need to put the parentheses on this since it is an addition problem. From there, we want to simplify by combining like terms. So I'm going to bring down my x squared. I'm going to bring down my minus 2x. And I'm going to combine my constants to give me 10. So f plus g of x equals x squared minus 2x plus 10. Okay, example B. Let's go ahead and find f of 5 and g of 5. So f of 5, if we plug it into our f equation, we get 5 squared plus 3. This is 25 plus 3, or 28. G of 5, if we plug into our g equation, we get 7 minus 2 times 5. If we simplify, we get 7 minus 10, which is -3. So now we're going to subtract these two values. We get 28 minus -3. This is equal to 28 plus 3, or 31. And that's our final answer. Okay, division. Division is actually one of the easiest ones to work with because we're not going to have to worry about combining like terms or multiplying or anything like that. Quite often it's just put one function over the other. And so if we go ahead and find the function, remember that division, this is just going to be f of x divided by g of x. And so if we plug in, we get x squared plus 3 over g of x, which is 7 minus 2x. And as I said, you can't really do anything with it from there. That takes care of example C. And finally, let's evaluate a division function. let's go ahead and plug in 3. So if we plug this into our function that we found right here, we're just going to replace all of the x's with 3's. So we get 3 squared plus 3 over 7 minus 2 times 3. If we simplify, on top I can square the 3, we get 9 plus 3 over. On the bottom I can multiply, we get 7 minus 2 times 3 is 6. 9 plus 3 is 12. 7 minus 6 is 1. And now if we divide, we do get 12. So f divided by g of 3 is equal to 12. All right, that takes care of our algebra of functions. As I said, this is an introductory thing, so we're not going to put a lot of emphasis on it, but you will see this in future math classes, so kind of keep these notes handy for next semester. That finishes off Module A. The next module that we're going to be looking at is polynomials, and so if you have any questions, please contact me, and I will see you again shortly.